Good morning, everybody. Today we are looking at chapter 12.1 in your textbook. This is on page 933. If you can see that, 12.1 is what we're doing. And a lot of what we're doing today is things that we have already discussed. So for our learning goals today, we want to convert exponential equations into logarithmic equations. And we've actually done this. We've talked about this before using our little e that we trace. Same thing with converting logs into exponentials. We would do that e, and I'll write these down in just a second. Today, the big thing what we're going to do is now write these, and we're not just going to write them, we're also going to solve them. Okay, so we're going to actually solve and find equation values. We're not going to worry about estimating values on a number line because we can actually solve them. That makes a lot more sense. And we're going to evaluate logarithmic expressions as well, and evaluate simply means to solve. So that's what we're going to do. Alright, so today we're doing a lot of converting, but then in addition to converting, we're going to now solve. Okay, so a couple things I want you to recognize, and that is, if you have an exponential function, it's always going to be written in the form base, I'll do some colors here so you can see a little better, raised to some power is going to equal what we call an argument, which is just your answer. And this is going to be the exact same inverse, remember exponentials are inverses, of a logarithm function. Hope I have enough room here. And in a log function, you're always going to start with log, and then the base goes as a subscript. This base, whatever it is, will match that base. And then we're going to have our argument in parentheses. And in a log function, that equals the power. I'm running out of room, but you get the idea. And then this obviously can go back, because this is an inverse of the exponential. So this kind of just is the map that you can hopefully understand and use and write. Base power equals argument for an exponential function. Notice the power is what you're raising the base to. The power is always the answer for a log function. And the argument is always the answer for an exponential function. And if you understand that, then we can solve these equations very easily using a calculator, of course, but you got to be able to write them correctly. So that's what we're going to be worried about today. Should be a nice, easy day, and we'll move on and get you caught up with other things. And good luck this week if you're going to be taking any of the end of course exams or STAR tests, which will obviously slow us down a little bit if we need to, but not a big deal. Alright, flip it over. On the back, we are going to make sure you know how to write all of these different equations. Okay, some of these you should already know. As I'm looking, this is an exponential form, and it's telling us, I'm going to put colors on all this. I'm going to color it so you can see it a little better. We have the number 12 to the power of 2, which equals 144. Now, from what I just showed you earlier, 12 would be our base, 2 would be our power, our argument or our answer is 144. We're going to rewrite that in log form. So we're going to write the word log, and our base is 12. That's going to be a subscript. It's always under. And then we're going to put our argument of parentheses 144, and it's going to equal our answer, which is our power of 2. Remember again, logs are always answered in power 2. Okay? I'm going to let you do this one backwards. I'm going to let you do this one. I'm going to focus on this one, last one, because we haven't talked a whole lot about this. This is in log form. And by the way, remember if you have base, I'll write this down for you. Power, argument. The little e trace that we've talked about, I'll do it with a colored pen here. The little e trace is you always start at your base. Argument, then power. There's the e that we trace, and it tells you the order that you would write these in. So you're going to write the log, then the base, then the argument, then finally the power up here, and that's the e that we're referring to. And the reason that's important is because we're going to come down here, and remember you always got to isolate your base and find your base. In this one we have this ln, which if you remember, ln means what's called the natural log. All that means is that you are in the base of what's called e. And if you've forgotten, don't forget, because I'm going to tell you again. E is second divide on your calculator. There's the E button. If you hit enter, E is the number 2.718 approximately. And again, from your last test, hopefully remember this, You use E for two reasons. Number one is population growth, and number two is continuous compounding. Those are the only two times you use base E. And if you see natural log, like in this problem I see natural log, I'm going to color it this for you, 20.086, and that's going to equal 3. What I'm going to do is I'm going to rewrite this as an exponential. So remember, if you have log, and by log I simply mean any log, the natural log is a type of log. You're going to have your base down here. You're going to have your argument. Oops. And it's going to equal your power. You can also trace your E if you're going to go backwards. You start at your base, to the power equals the argument. There's the E. So when I look at this, I'm going to say, well, what is my base? Well, since it's natural log and there's no base written down there, it's automatically base E. So I'm going to come over here and I'm going to copy that's my base. I'm going to put an E. And then I'm going to raise that to what is my power. In this case, my power is the number 3. And it's going to equal whatever my argument is, which in this case is 20.086. And again, you can always check your answers. You can always check them. For example, number 1, if I had 12 to the second power, I should get, oops, there it is, 144. Okay, this is a correct equation. If I had any other order, like 12 to the 144th power, oh, my answer is too big, overflow. That means it's too large of an answer. It won't show up on your screen. I didn't get 2. So if I ever write it in wrong, if I did 144 to the second power, well, that's definitely not 12. Okay, so you can always check your answers nice and easy. Now if I come over here, log base 12, remember log base, you can do alpha window and hit number 5. And if you have this feature, then you can just type in 12 and 144, and there's your answer of 2, so it matches. If for some reason your calculator has that crossed out, all you have to do is make a fraction. We're going to do log button, which is right next to the 7. Log of 144. On the bottom, we're going to type in log of the base, and I always remember this because that base, if I cover it up, that looks like the numerator, and this 12 is kind of a denominator if I imagine there's a line right there. So log of 144 over log of 12, that gives me the same answer of 2, so I've done this correctly. I can check these real quick. E raised to the power of 3 equals, hey, there it is, 20.086. They just rounded that number to 6, so that works. And over here, remember, they didn't have this E there before, so I just have to type in natural log, which is next to the 4, natural log, 20.086, and when I hit enter, I should get 3. Pretty close. 3 is good enough. So I want you to complete all of these values in your table here. And check your answers. These two down here are really going to be the important ones, and the reason they're important is because these are now where you get variables involved, and this is what we're going to be solving next. So go ahead and pause the video, finish this up, check your answers, and then move on to the next part. Okay, so hopefully now you have finished all of that, and what I want to do is move along to number 4 here on page 936. We're going to solve these equations. Okay, page 936 down here at the bottom, we're going to go ahead and solve number 4. All right, and to solve these, we're going to find the value of the variable. Some of them already have the variable as your answer. For example, in this one, we are in, I'm going to rewrite this so you can see a little better. We're in log base 8 of 64. I'm putting colors, so hopefully this reminds you of what's going on, equals n. Since this equation already equals what n is, all we have to do is use the calculator and type this in. So I'm going to use my log feature, and I know, hopefully now from last chapter, it's going to be log of 64 divided by log of 8. So when I come to my calculator, I'm going to type that in, and it would be log 64 over log 8. You don't have to put parentheses at the end of them. I like to make sure I close it. So log 64 over log 8, that gives me the answer of 2, which means that n in this case equals 2. And that should make sense because remember, log is the inverse of an exponent, which means 8 to the second power has to be 64. And we could always check that if you wanted. 8 to the power of 2 is 64. But that would be an example of how you solve. Okay. So I want you to find all the n values that you can. I'm going to do one more here, and some of them you'll have to rewrite. For example, e down here, I'll do this one because it's a little bit tricky. This one says log base n of the cube root of 49 is going to equal 2/3. Now on this one, we don't get equals n, equals our variable. So what we're going to have to do here is we're going to have to rewrite this into an exponential equation. And hopefully you can remember, I'll trace your e so you know. There's your big E. So it's going to tell us that we put the base n to the power of 2/3. And it's going to equal the cube root of 49. I want you to think about, how could I get n by itself? Right now we don't know n, but we do know its power. Hopefully you reminded yourself that whenever you need to get rid of a power, you can flip the power. And if you flip the power on one side to cancel it, you can put that power on the other side, so from here to here. Alright, so what we are going to do is we're going to take the 2/3 power and we're going to eliminate it so we get n all by itself. And I'll do it in pink here so you can see it. We are going to multiply this by the 3/2 power, because then 2 times 3 makes 6, divided by 3 times 2 makes 6. This power will cancel. So this power is now gone and we have n by itself. And we're allowed to do that as long as we raise this power, this value over here, to the 3/2 power also. And that will give us n by itself. So I'm just going to write it over here. N is going to be this value right here, the cube root of 49 all to the 3/2 power. So I'm going to show you how to type that in. Hopefully you remember where cube root is. If not, it's the math button. We're going to hit math, and then right there, number 4 is the cube root. We're going to type in 49, and then I'm going to go out to the side here. I'm going to raise that to the 3/2 power. And I get the total number of 7. Now, let's say I wasn't really sure if that was right. Okay, I wanted to check it. So what I'm going to do is I'm going to come back to my original equation. I'm going to plug in 7 where that n is. And one thing I like to do is I always like to store my answer. So if you hit this STO, it stands for store. It's right next to the 1 button. If I hit store, I can store it as an alphabet character, A, B, C, in the calculator. If I do alpha, and then I always like to do the A. Store alpha A, hit enter. Now, anytime I hit A, it will automatically assume that number 7. And it's good to always store your answer that we don't have to remember it. So I'm just going to come over here and I'm going to type log base n, which is our answer 7, of cube root of 49. It should equal 2/3 if I did this right. So I'm going to come over here, I'm going to do a fraction because I'm in a log funky base window, number 5. If you have this, I'm going to type in 7 there and math cube root 49. And 0.666667 is 2/3, so that is correct. If I didn't have that feature, I would do alpha y equals, and I would type in the log of cube root 49 over the log of my answer, which was A. I don't have to put the 7 if I wanted just to what I stored, and I would still get, and that's an actual better one because now I see exactly 2/3. So with your table, I want you to do B, C, D, and F, and tell me all of the answers. Then I want you to find the answer for number 5, and check your answers off. When you flip it over, let's see, page 937, I want you to do 5. I want you to do A here. Just find the answers here. C here, find that answer. D here, find that answer. Alright, go ahead and do that. Pause the video and then check your answers when you are finished before we move on. Okay, hopefully you paused that and you checked them out. If you flip over to the next part, problem 2, we're going to skip. So you can skip page 938, 939, 940, and I want you to come to 941, and kind of like what you were doing before, I want you to solve these answers and check them off. Log base 2 of 10, what does that equal? Log base 5 of 4, log base 4 of 300, and log of 2500. Remember what this base is if you need that. Okay, tell me all those answers. When you flip it over, 942, you can cancel that page. We don't care about it. And then we're going to come to number 6 on page 943. And again, we are going to solve these answers. I want to know what the base is here, here, and here. All of these should have an answer. Determine what that base is. And when you're finished with that, you may check all of your answers with my key as it's at my desk. It stays at my desk, but you are free to use it. And once you are good and everything is correct and I know that you know how to solve these equations and rewrite these equations, I will give you the homework page and you can complete that today for full credit. Okay, don't leave class without turning that in unless you have an extenuating circumstance, in which case you can talk to me before the bell rings. Alright guys, you now are Completely done with 12.1, and we'll go ahead and turn that in before class again.